do we humans perceive the things around us? We have 5 senses that help us to interact with the world around us. These are sight, hearing, taste, smell, and touch. Eyes help us to see things, ears help us to hear sounds, we smell with our nose, taste with our tongue, and the sense of touch is provided by our skin. Of course, all senses are important, but the sense of sight is the most important. Here is an interesting fact. We perceive almost 80% of the world around us by using our sense of sight. We see objects around us with our eyes, but then why don't our eyes see these objects in the dark? The answer to this question is light. We are able to see the objects around us because of the light coming from these objects. The light from these objects travels in space and reaches our eyes. When it's dark or during nighttime, as there is no light, we are unable to see these objects clearly. Some objects can generate their own light. For instance, the sun, the fluorescent bulbs, burning candles can generate their own light. The objects which generate their own light are called the luminous objects. Almost all of the objects that we come across cannot generate their own light. The table, a chair, wall, paper are few of such examples. Such objects are called as non-luminous objects. But I just told you that we see objects around us because of the light coming from them. And if objects like these cannot generate light, then how come we are able to see them? We are able to see them because of the reflection of light. These objects reflect the light to our eyes. What light are they reflecting? Where is the light coming from? This light is nothing but the light coming from the luminous objects. So how can we summarize this? We are able to see non-luminous objects because they reflect the light of the luminous objects falling on these surfaces. Let me repeat. The light coming from the luminous objects falls on the non-luminous objects. Non-luminous objects then reflect this light, and this reflected light travels towards our eyes. And that's why we see the objects. In the daytime, we are able to see blue skies, the white clouds, and the green grass because the light from the sun is getting reflected by them and traveling towards our eyes. At night, we are able to see the moon because it is reflecting the light from the sun. Note that moon is non-luminous and it cannot generate its own light. As I said earlier, most of the objects that we come across in our daily life are non-luminous. We only see them because they reflect the light. Step inside a dark room, light up a torch and point it at the distant wall. Look carefully at the path of the light coming from the torch. You will see tiny dust particles in the air. What is the reason for this? Why are you able to see these particles? You are able to see the dust particles because the light from the torch is getting reflected from their surfaces and traveling towards our eyes. We also see the same thing in a very dimly lit room where the only source of light is a small amount of sunlight coming from the window. In this video, we saw that the reflection of light plays an important role. Some objects like the sun, burning candle and the fluorescent bulb emit light of their own. They are also called luminous objects. Many objects around us are non-luminous, that is, they cannot generate their own light. However, these objects reflect the light from the luminous objects from their surfaces. And because of this reflection, we can see such objects. In which direction do the luminous objects emit their light? They emit light in all the possible directions. Consider a fluorescent bulb which is glowing. It is emitting light in all the directions. Let us denote each direction with a straight line and an arrow on it pointing in the direction where the light is traveling. So all these arrows represent various paths along which light is traveling. These arrows are what we call rays of light. Here's how we define a ray of light. A ray of light is a straight line path along which light travels. So now we know that light emitted by luminous objects travel in a variety of directions. Suppose rays of light from this fluorescent bulb fall on the surface. It being non-luminous reflects these rays, and these reflected rays travel along a certain path. Consider this plane surface. Suppose one of the rays of light from the bulb strikes at this point. This is called an incident ray. We know that this surface will reflect this ray, and the reflected ray will travel in this direction. Why only in this direction? Why not here or here? This is because rays of light obey certain laws of reflection when they strike any surface. Draw a perpendicular to the surface at the point of incidence. This line is also called normal. Here are the two laws of reflection that any light ray obeys. To understand the first one, we first need to know what angle of incidence and angle of reflection are. The angle of incidence is the angle made by the incident ray with the normal. It is denoted by I. The angle of reflection is the angle made by the reflected ray with the normal. It is denoted by R. So our first law says that the angle of incidence is always equal to the angle of reflection. I is equal to R. Here, as I is equal to R, if the incident ray strikes at this point, then the reflected ray will travel along this direction only so as to keep the measure of R same as I. If I move the incident ray here, then the reflected ray will also move to keep the measure of R same as I. I is always equal to R. Okay, so this was about the first statement. What about the second statement? The second one tells us that the incident ray, reflected ray, and normal all lie in the same plane. So if I draw this scenario on the piece of paper, I will get this. Incident ray, reflected ray, and the normal, all three are in the plane of the paper. The second law tells us that they will always be on the same plane. For example, if the reflected ray is in this direction instead of this, then the diagram will look like this. The incident ray and normal are in the plane of the paper, whereas the reflected ray is not in this plane. This violates our second law, and hence this ray will not be reflected in that direction. This is just not possible. It can only be like this. I will be equal to R, and they will lie on the same plane. I hope both the laws are clear now. In the next lesson, we will see an experiment based on this concept which you can easily perform at home.